Hello chemists, welcome again to the Chemical Earth series. In this video we're going to look at classifying elements. One of the things that's very important is that a lot of the early part of the chemistry course should be overlapping with some of the material that you've covered in your junior years, in even years 8 as well as 9 and 10. So hopefully some of what you're seeing is just a review and a revision or a refresh of what you already know. What we'll try and do is add a little bit to each of these pieces of information as we put them in and see if we can extend some things on a little bit. So the first thing we want to look at is how we classify elements, and there are a lot of ways of doing that, but perhaps the best and most comprehensive way of classifying elements is with the use of the periodic table. It is a really important tool for a chemist, and one that is, I guess, takes a lot of practice to use effectively. There's an endless amount of information that you can get from the periodic table, and the more effectively you can extract that information, the more likely you will be to be successful in your exams. The periodic table is separated into groups which run down from the top to the bottom in the way that columns do in a spreadsheet, and periods go across in the way that rows do in a spreadsheet. So periods are horizontal and groups are vertical. Periodic groupings are based on similarities in the properties, both the physical properties and also the chemical properties. And what we find is a number of different trends. So even when specific elements are placed in the same period or in the same group, there will be certain reasons why those elements are placed in those particular locations, and there will be relationships between those elements and other elements in either the same group or the same period. But there will also be some fairly recognizable trends that are occurring as we move along a period or up or down a group. Two specific groupings that we will be looking at. The first is the state at room temperature. Now this doesn't split our elements into a lot of, or certainly not into even groupings, because there are only two that we know of that are liquids at room temperature. Most are solids. Pretty much all of the metals, with the one exception that is a liquid, which is mercury, are solids at room temperature. And then there's a small number of non-metallic elements which are gases at room temperature, things like nitrogen, hydrogen, oxygen, and so on. The other way that we can group elements together is on the basis of their metallic nature. The elements that behave like metals, funnily enough, are called metals. The ones that have properties that are counter to those of the metals are called non-metals. And then there are certain elements that seem to have some properties of both groups, and these are called the semi-metals. Metals tend to occur on the left-hand side of the periodic table, whereas the non-metals tend to occur on the right-hand side, and somewhere in between are where the semi-metals reside. Once again, when we're looking at these different types of groupings, we can remember that they will be placed in particular groups on the basis of their physical or chemical properties. So state at room temperature is certainly a physical property because it's related to melting points and or boiling points. The metallic nature actually has components of physical and chemical properties. There's certainly some aspects of appearance and conductivity that are part of physical characteristics, but also the way they behave in chemical reactions would be part of their chemical characteristics. So when we're looking at physical properties, we want to determine whether an element falls into one of those three categories. It's either a metal, a non-metal, or a semi-metal. So how do we do that? Well, we need a good set of properties. One individual property is not going to be sufficient to allow us to classify things completely. So we use a range. We can include luster, this is the appearance and whether the particular element has a shiny surface. How hard it is. You may have heard of the Mohs scale. 1 is talc, which is where we get talcum powder, and it goes up to 10, which is diamond, which is the hardest substance that we know of. Density. Generally speaking, metals will be more dense than non-metals. Mechanical strength. So how easy it is to break. Malleability. This relates to its ability to be hit with a hammer, but I guess more importantly, whether it can be shaped and whether we can make plates or sheets out of the element. And you'll see some examples of that in your practical. Ductility refers to whether or not we can draw it into a wire. So something is ductile if we can make a wire out of it. So a good example of this would be copper wire that is used quite extensively in electric circuits. Copper is a very good substance to be made into a wire for conductivity, and so therefore we would describe copper as being very ductile. Electrical conductivity is important, so whether or not the element will conduct an electric current or allow an electric current to pass through it. Likewise for heat, thermal conductivity is relating to heat and whether or not the substance will allow heat to be transmitted through it. Solubility, particularly looking at solubility in water, whether or not the substance will dissolve in water. Its melting point, which is the point where we go from a solid state to a liquid state. And also the boiling point, where we go from a liquid state to a gas. So if we're looking at grouping each of these elements together, then the first thing we want to do is look at the metals. Now the metals are probably the biggest group. In fact, there's no probably about it. They are the biggest group. And they are a very varied group, a very broad range of different properties that unite the metals. Despite that, there are a few characteristics that are reasonably good generalizations for most metals. Most of them have a high density. Most of them are good conductors of both heat and electricity. Most metals are malleable. You can shape them with a hammer. Most are ductile. You can make a wire out of them. Most are lustrous. They have a shiny surface. Some metals are very reactive, and that shiny surface can be lost if they react with oxygen in the atmosphere and oxidize. But if you remove that surface of dullness, then often the shiny metal beneath will come shining back out. And most of them have high melting points and also high boiling points. And of course, there are a couple of exceptions. Hg is mercury, which we know is a liquid at room temperature, and Ga is gallium, and it also has a lower melting point for a metal. The important thing about properties is that in chemistry, properties go with uses, and we're going to be looking very much at the relationships between property and use as we go throughout our chemistry course. So some interesting things about gold. Gold has a high density. This symbol is the Greek symbol rho, and it stands for density, just in case you're not familiar with that symbol. There are a lot of Greek symbols that are used in science, and we'll see a few of them as we go through this course. Gold has high conductivity, it has high malleability, and it's able to be shaped into all sorts of different shapes, as you can see with the ferros. It's able to be drawn into a wire. It's extremely lustrous, a very, very shiny metal. It has a high melting point, but not as high as some of the other metals. But it's actually got quite low reactivity. We wouldn't want the gold in our jewellery to be reacting with oxygen and becoming dull or dissolving when we put our hands in water or when we walked around in the rain or swam at the beach. So the reason that gold has such a marvellous range of uses in jewelry is the fact that it has a combination of properties that make it ideal for that specific purpose. Non-metals are a smaller group than the metals, but they're still fairly variable in their properties. They tend to exist mostly in the gaseous state at room temperature and have a variety of different forms. Some of them form different types of crystals, such as sulfur, and others are diatomic gases, such as oxygen. They are dull. The opposite of lustrous or shiny is dull. So non-metals are dull. They are poor conductors. They're often described as insulators. They do not conduct heat or electricity particularly well. They're neither malleable nor ductile. In fact, we describe them as brittle. If you hit them with a hammer rather than shaping, they will shatter. They have a much lower density than metals and also lower melting points and boiling points. And that explains why many of the non-metals actually exist as gases at room temperature. Semi-metals are somewhere in the middle. Sometimes semi-metals are referred to as metalloids, and there are only a small number of these, and they're relatively unique as a consequence. But one interesting thing about them is that a couple of them have been used as the basis silicon and gallium for semiconductors. So materials that have some properties of conductivity but are not as good conductors as the metals are. So these ones in the middle show some characteristics of both metals and non-metals. So, a couple of questions. Which of the following, sulfur, nitrogen, phosphorus, mercury, or carbon, would you expect to have A, the lowest melting point, and B, the best electrical conductivity? Well, at room temperature, sulfur is a solid, nitrogen is a gas, phosphorus is a solid, mercury is a liquid, and carbon is a solid. So therefore, if we're looking at melting points, we want to pick something that we know is pretty low. So melting point is the change between a solid and a liquid, and at room temperature, nitrogen is already a gas. So we've got to cool it a long way down to get it back into the liquid to solid range. So nitrogen would be the answer for the first one. Now the best electrical conductivity, well, we know that metals are the better conductors. Sulfur is a non-metal, nitrogen is a non-metal, phosphorus is a non-metal, and carbon is a non-metal or maybe a few little properties of semi-metal, but it's certainly not metallic. So the only one that we have here is mercury. So the best electrical conductor amongst this group would be mercury. Thanks for watching.